Hi everybody. So today what we're going to start is the chapter about probability. But before we jump into probability, one of the things we have to look at is the number of ways that you can do something, because that's important when you're figuring out probability. So today we're just going to look at how do you figure out how many ways you can do something. And we have 3 different methods, and you use each of these in a different situation, but we're going to have the fundamental counting principle. That's one method we'll use. We have permutations, that's another method, and then we have combinations. Each of these has their own role. So let's start off with fundamental counting principle. All right, to take you back to middle school, if you'll remember, you'd have to make these tree diagrams. And so maybe you had your 2 favorite shirts. Like you had this red shirt and you had this green shirt. And with that red shirt, you could wear jeans, or you could wear khakis, or you could wear shorts. But you could also do that with your green shirt. And then for each one of those, you would have these shoes that you would have options for. And so it would get kind of crazy drawing this tree diagram, but it showed you all the different outfits you could have. All right, we're not going to be doing that so much, as what I'm really interested in is just how many of these outfits are there. I don't care what they are so much as how many are there. And so that's the fundamental counting principle. To figure out how many different outfits I would have, I would simply take the number of shirts that I have, which I said was 2, times the number of pants that I have to choose from, so that would be 3 times, and I kind of had 4 different shoes here that I could wear with them. So if you multiply that all together, then that means I'd have 24 different outfits. Okay, that's the fundamental counting principle. It just means that you multiply all the different options together. You'll see it in the book kind of like as an N times M, but it's not restricted to only 2 things. You might multiply 8 things together. It's fine. You just multiply the options. Okay, now the thing with fundamental counting principle is that the order is important and you are allowed to do repeating. So those are kind of the things that are going to distinguish which method we use. And so anytime the order is important and you can repeat values, then you're going to use this fundamental counting principle. So let's look at some examples. For instance, phone numbers. Okay, the order that you type in the numbers in your phone is important. If you mix up a couple numbers, that's someone else's phone number. That's what we mean by order is important. And yes, you can repeat numbers. You might have 2 4s in your phone number, and that's fine. So let's go through how many different phone numbers could we come up with. And so we kind of look at it like, well, there's 7 numbers. And so how many options do you have for the first number? Well, there'd be 10. 0 through 9 is 10 different digits. And since you're allowed to repeat, you would still have 10 options for the next one, and 10 for the next, and the next, and the next, until you get to the point where, well, that's really just 10 to the 7th power. Okay, just to hurry us along today and to keep my notes clean, I'm really just going to leave that 10 to the 7th there, but in your assignment, I would expect you to type that in your calculator and get me an answer. All right, but again, I'm going to keep it as 10 to the 7th just to keep us hurrying along. Now, what's nice about the fundamental counting principle is that you can start tweaking it a little bit. As long as you throw in some restrictions, you can change it up a little bit. So for instance, maybe these phone numbers, well, it's not really 10 to the 7th different phone numbers because there are some restrictions. You can't let the first number be 0 because that would be calling the operator immediately. You can't let it be 1 because that would be long distance. And so we actually have some restrictions. Instead of having 10 options, I really only have 8 options because it can't be a 0 or a 1. But that's only on the first number, so the rest of them could stay the same. All right, so this was a 10 million, so now we're down to 8 million different phone numbers that we could come up with. All right, let's make it even trickier. Well, those are not the only restrictions that you have. Also, you wouldn't want to have a phone number that the first 3 digits were 911. You'd be getting called all the time. Actually, 411 is information, so that's not allowed. 211 is like a volunteer hotline, and really they've pulled out anything 11. 511, 611, any of those are not allowed. So of these 8 million phone numbers that I've got, how many of them are going to end up being a 911 or a 411 or that kind of thing? How many different phone numbers start like that? Okay, so here's what I'm going to do. I'm going to try to see how many phone numbers start off with a 911. Okay, so you'd start off with your 3 digits, and then you'd have your 4 after digits. But to start off with, for it to be a 911, well, then I'd only have one option for the first number. It'd have to be a 9. I'd only have one option for the second number. It would have to be a 1. And I only have one option for the third number, because it also has to be a 1. But once that's out of the way, then I don't have any more restrictions, and I would just have 10 times 10 times 10 times 10. And then I'm actually going to tweak this even more, because this restricts it to just 911. But remember, it can't be 411 or 211 or 711 or anything else, so I'm going to change this first number. I actually have more than one option there of numbers that would be like this. Now, it still can't be 0 or 1, but it could be 8 other numbers. And so then what I end up with is, remember, we're always multiplying these together. Sometimes I don't get that dot in there, but I'm always multiplying those. So I actually have 80,000 phone numbers of this 8 million that really won't work. So then we start reducing that, and I'm sure there's many, many other restrictions that we're not aware of. But this is what I like about the fundamental counting principle, is because you can start tweaking it, changing some numbers, however you want. All right, let's try again with some license plates. You'll have some license plate problems on your homework. How many different license plates are there? Well, when I was a little girl, we used to have license plates that had a letter followed by 5 numbers. And as a this first letter would always be the first letter in your last name. Okay, so how many options then would we have for this first? If you're thinking you work for the state and you're making license plates, how many options do you have for the first one? Well, since it's a letter, you'd have 26 options. And then you would have numbers, so after that it's 10. Remember that the order here would be important. If you switch 2 numbers, that's someone else's license plate number. You are allowed to repeat. You can have the same number more than once. And so then you end up with this 2, 6, 1, 2, 3, 4, 5. Oops. Okay. And so I have 2,600,000 phone or license plates. All right. Now, what happened though is now it seems more prevalent to have numerous cars in your family, and you might have 3, 4, 5 cars in your family. And so they start running out of license plates. They need more options. And so now what you see is a number, letter, letter. All right. So if you look at it like that, then you would have 10 options for your first number, 10 options for your second, 10 options for your third, and then you have your letters, so it goes 26, 26, 26. And you multiply those out. And that gives us, well, because there's more letters, it gives us more options. Actually, though, they also, I don't know, I just remember they always used to be like this, and then all of a sudden I started noticing some of them actually go letter, 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 number, number, number. Do you know what yours does? Does it do that? Basically, you're going to get the exact same number here. And I don't recall right off what this is. You can type it in your calculator. On your homework, you would give me an answer. It's something like 17.5 million. So together, you're at like almost 35 million license plates that are possible. That's a big jump from what they used to do. Okay, so let's do something with some restrictions. All right, so one of the things that you have to consider if you work for the state and you're making license plates, you can't really put any naughty words on there. And so, for instance, if you're looking at all of the license plates that go number, and then they are angle, side, side, let's say. Well, how many license plates actually do that? Well, you'd have 10 options for your first number, 10 options for your second number, 10 options for your third number. Let's get rid of this. We don't want this in here. Okay, so if it's going to go angle side side, how many options would you have? Well, you'd have one. It's got to be an A. And for the next one, you'd have one. It's got to be an S. And this one is an S. Okay, and so it's 10 times 10 times 10. That's 1,000 license plates that say angle side side. And actually, it's 2,000 because remember that it could go the other way. So it would be 1, 1, 1, and then 10, 10, 10. So it's really 2,000 license plates that they can't make because of the naughty word. And so that's out of your 35 million-ish that we had up here. But angle side side's not the only one. You sit there and think. Okay, don't sit there and think. Don't think of all the naughty words. But for every 3-letter naughty word, you'd have to cut 2,000 license plates out of our total. Okay, so that's fundamental counting principle. I like it. It's very adjustable to restrictions that they put on it. Let's move on. Next one is permutations. And on permutations, the order is still important, okay, but you're not allowed to do repeating on permutations. All right, so an example of that might be like in a dog race. Now, if you're at like the dog track and you're picking like who's going to get first, who's going to get second, who's going to get third, and you're looking at how many different ways could this race end, well, you'd have 8 options for the first dog. But since there's no repeating, you can't have Fido finish first and second, and so you would only have 7 options for your second place. And then you'd only have 6 options for third place, and so forth, and on and on and on. Okay? And so whatever 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is, would be how many different ways that dog race could finish. Now, actually, you're not going to do that. We do have a button that does a number multiplied by every number underneath it. It's actually looks like this. It's called 8 factorial. And you type that in. That's in your, if you look at your calculator, it's in math. And then you scroll over to probability. And you'll see it as one of the options. I think it's the 4th option there. So you would type 8, and then you would go to that button. Okay, so now there's a lot of ways this race could finish. And so obviously this is all about, you know, one of the places you see a lot of this permutation and probability is in gambling. And so if you think they're not going to expect you to make a bet where you could pick how this race is going to finish because there's just so many ways. So really what they do is they kind of reduce it and say, well, maybe one of the bets would be, can you pick the top 3 in order? And so that would be more something like this, where there are 8 options for the first dog, 7 options for the next, and then 6 for the third. That's much more doable. 8 times 7 times 6 would just be, what do we get? 336. Okay, so there'd be 336 ways that that race would finish. All right, you can't really use your factorial button on your calculator because it doesn't go all the way down to 1. So what you kind of want to look at is how this one compares to the previous one. Really, it just is not including that right there. And so I'm multiplying by that. So if I were to do 8 factorial, I could really just do 8 factorial and divide it by the 5 factorial that I'm not using, and it would get me this 8 times 7 times 6. Now, that's probably a little bit tedious to do in your calculator. I would be more inclined just to take the 8 times the 7 times the 6. But when you start working with a lot of numbers, sometimes this is a better route. And in fact, this is common enough that it has its own button. We don't even have to do that division. It's called a permutation. And it is in that same place in your calculator, and it's written like this. And what that means is you have 8 objects, and you're going to choose 3 of them in order, because it's a permutation, and order is important. So the way you'd enter that in your calculator is you'd type in 8, then you'd go to math and over to that probability, and it's number 2. And then you'd press 3. And so you see that you get that 336. Regardless of which method you use here, you're always going to get that 336. All right. This right here is basically the formula of what you're doing. You're taking your n factorial, that's your 8 factorial, then you're doing your n minus r, and since I was only choosing 3, n minus r would be 5. And that's what's going on, but you're using the button in your calculator to do it. All right. A permutation, again, is an arrangement of objects, and so I always think of it as a placement, like you're placing things. Anytime you're trying to place them in a certain spot, then you're going to be doing permutations. Now, one of the places that we use permutations is when we're looking at, and this is actually kind of how your spell check works behind the scenes in the code that's written when you're typing in Word and it notices you misspell a word. It's looking at all the permutations. Our example here is going to be of Mississippi. How many different ways could you mess that up? How many ways could you rearrange those letters? Well, since there's 11 letters in Mississippi, you could think of it like this. You have 11 options for the first one and 10 options for the next letter, and 9 and 8 and 7 and so forth, all the way down to 1. And that would be fine if every one of these letters was different. But we're looking for the distinguishable permutations. In other words, if I accidentally mix up these two S's, I'm never going to notice because they look the same. And so I am going to start off and I'm going to do this 11 factorial. But what I have to do is I have to divide out all the times that I switched a couple letters that I'm not going to know the difference of. So what we do, and here's your formula up here, you take your n factorial, in this case it's 11 factorial, and you divide by any of the repeated letters factorial. So S is in there 4 times, so I'm going to divide by 4 factorial. I is in there twice, so I'm going to divide by 4 factorial. I'm sorry, I is in there 4 times. And then P is in there twice, so I'll divide by 2 factorial. And you type this all in your calculator. And be careful. Make sure you use parentheses around that denominator because you're dividing by all of that stuff. If you don't do those parentheses, you're going to get the wrong number there. One of the things you might start doing, though, is also think, well, 2 factorial is really just 2 times 1. Do we really need to type that in as 2 factorial, or could we just call that 2? You know, look for those shortcuts when you're multiplying stuff together. All right, so let's do a couple examples where we're doing that fundamental counting principle or you're doing the permutations. So this first one, at a restaurant you have a choice of 8 different entrees, 2 salads, 12 drinks, 6 desserts. How many different dinners can you come up with? Okay, that's like my outfits. I'm basically just doing fundamental counting principle. I got 8 entrees to choose from, I got 2 salads, I got 12 drinks, and 6 desserts. Multiply it all out, tells you how many different dinners you could get. Okay, this next one's a little trickier. It says a multiple choice test has 10 questions with 4 answer choices for each question. How many ways could you complete that test? Okay, take a second right now and I want you to make a guess. I'm going to wait. You make a guess. Multiple choice test, 10 questions, it's A, B, C, or D. How many different ways could you do that test? Go. All right, did you say 40? Because it's really tempting to say 40, but that's not right. Let's look at it. Let's stretch it out like fundamental counting principle. You got 10 questions. I don't know how many that is. Okay, so how many options do you have for the first question, for question number 1? Well, it's A, B, C, or D, so I have 4 different options. And then I'm going to do another question, and I'm still going to have 4 options. I can do A again. It's okay for it to repeat if it needs to. All right, the next one, still 4, still 4, still 4. So it's not 4 times 10. You should have ended up with 4 to the 10th power. If it was 5 answer choices, maybe it's A, B, C, D, or E, well then you'd have 5 to the 10th power. Okay, this one is you're trying to place people in a seating chart. And so, again, you have some questions on your, I'm trying to do, you really need to kind of get good notes on each one of these because every one of them has problems just like it on the assignment. So this is important that you're taking some good notes as you go here. In a class of 22 students, how many ways can I create a seating chart? All right. Well, the order that I place the students is important. That's what makes it a seating chart. I'm not really allowed to repeat here, though, because I've got, I can't put Bobby in 2 different seats. I can't say his name twice. Okay, so that would be permutations. So that would be permutations of, I have 22 students, and I'm actually placing all 22 of them. Another way you might think through it, you could even do fundamental counting principle with it. You'd have 22 options for the first kid, or for the first seat, and then you can't repeat. So this is that thing where you can tweak this to not repeat. You can say there's only 21 options for the next seat, and then 20 and 19 and 18 and all the way down to 1. So really it's just 22 factorial, which would actually get you the exact same thing that does. So either way would be good. Okay, in this class, how many ways can I select a president, a vice president, a secretary, and a treasurer? Okay, so I've got this class of 22 students. Now this time, order is going to be important here because being the president is different than being the vice president. So that's what's making certain that the order stays put. But I'm not allowed to repeat because Sammy can't be president and vice president. All right, so you could do, again, permutations. You have 22 students, but this time you're only choosing 4. Okay, you could also look at it as the fundamental counting principle. It would just be going down, but you'd only have to do 4 numbers instead of all 22 numbers. But that's not ideal because then it's not really 22 factorial. So maybe this is your best bet over here. Either way, get the same answer. All right, here's another example. Find the number of distinguishable permutations of the letters in summer, and then do another one and do it for waterfall. Okay, I'm going to do summer, then you pause the video and you do waterfall. All right, so for summer, there are 6 letters, so that's going to be 6 factorial, and I'm going to divide it by anything that gets repeated. Well, this isn't near as crazy as Mississippi. There's just 2 M's, so I'm just going to divide it by 2 factorial, and that's all I would do. Okay, pause the video, you do waterfall. All right, you should have for waterfall had 9 factorial divided by, there's 2 A's and there's 2 L's. These are being multiplied in here. Don't forget your parentheses, and you should have gotten 90,720. All right, on this example, we are choosing a committee of 4 from 7 people. Okay, so how many different committees are possible? So if you look at this as a permutation, you've got 7 people and you're choosing 4 of them. Okay, if you do that in your calculator, you're going to see that that's going to get you 840 different committees I could come up with. Okay, here's the problem though. When I choose Abby, Bobby, Charlie, and Debbie, that's really going to be the exact same committee as Bobby, Charlie, Abby, Debbie. Those are the same. And if I sit there and think of, well, I could have Bobby, Charlie, Debbie, Abby. That was considered a different group, but it's really the same group. If I have Charlie, Debbie, Abby, Bobby, that was counted as a different group, but it's really the same group. And so the question is, how many times did this group of Abby, Bobby, Charlie, Debbie get counted in this 840? Okay, well, really what it is it's just if you got 4 people here that you're choosing, and this is strictly from the ABCD, I'd have 4 options for the first spot. That was Abby or Bobby or Charlie or Debbie. And then I'd have 3 for the next, and 2 for the next, and 1 for the next. And so this one group of ABCD got counted 24 times. Okay, as did every group, really. And so what we end up doing is we take that 840 and we're going to divide it by 24. And that's going to tell us actually how many different groups I could come up with, or how many different committees. And so in this case, it's really 35 is what I got when I divided that, not 840. So what's different? Why was this problem different? Well, what's different is that the order is no longer important. When I'm picking a committee, I don't really care who I picked first. It's just a group of 4 people. It doesn't matter the order that I picked them. And so when you're dealing with a situation where order is not important, still can't repeat, that's considered a combination. And that works a little bit differently. It's still the same thing. Here's my permutation that I did, but I did an extra divide by however many I was picking. I was picking 4 kids, so I did an extra divide by 4 factorial. All right, that's how the formula is set up, but we're going to enter it in our calculator like this. And so if you do it, it's in that exact same place. If you did 7 math, go over to probability and do your combination, which is number 3, choose 4, you can see that you'll get that 35 that we got last time. Now, this is one type of notation, and that's usually what I will use, but you will find the book also has another notation for combinations, and they just do it as a 7/4 and put parentheses around it. It's not a fraction. Don't put a fraction bar in it. It's just 7 choose 4 written this way. These mean the same thing. Either way works for me. The book will probably use this bottom one more. The big thing you need to remember then is that combination order is not important. So I always think of combinations are like committees, because I know committees order is not important. But a permutation is when I'm putting people or dogs or whatever it is in a certain place. And so try to keep track of those 2 things. That's going to be a big thing, that you know which one of those to use. All right, so let's look at another example. It says, how many different ways can I choose the 6 winning lottery numbers from the numbers 1 through 30? All right, well, when you're choosing lottery numbers, the order that you pick them doesn't matter. You pick your lucky numbers and you just hope those are the ones they pick. They can come in any order. So if I'm looking at this, since the order is not important, I'm going to have to use combinations. It's the only one that says order is not important. So it'll be combinations. There's 30 numbers. I need to pick 6 of them to win the lottery. And so whatever that is, let's type that in. So it'd be 30, then you'd go math, probability, number 3, choose 6. All right. Just so that you're aware, don't play the lottery, 593,775 different options. And to be honest, it's really, when you're playing like the Powerball, it's not out of 30 numbers, it's more like out of 56 or something. It's even more. So this is optimistic compared to what reality is on the Powerball. Okay, so let's try one more example here. It says, how many ways can I select a group of 10 of you to go to a math contest? Okay, again, I'm picking a group of people. I don't care the order, I just need this group. So that's my clue. I've got to do combinations. It's the only one where order is not important. All right, and so it says a group of you in class. We counted up how many people there were. Let's go with that class we had earlier where there were 22 kids in it, and we're going to choose 10 of them. Okay, and so you just type that in your calculator, and that will tell you how many different groups I could pick to go to a math contest. All right, so those are your 3 things: permutations, combinations, and the fundamental counting principle. Each one has their own purpose. Use your notes as you go through your homework to help you decide which one to use. Good luck.